Hey everyone, welcome to the class. Can you see me? Can you hear me? Hi everybody, welcome to the Rankplus JEE English channel. We are all set to dive into one of the best sessions you have ever attended on the Calculus Masterclass. Can you see me? Can you hear me? I want a very quick good to go from all of you and I'm going to dive into the session straight away. Visible, audible? Visible, audible, everybody? Hello. A very Merry Christmas to each one of you out there. How's everyone doing? How has been your Christmas? How are the Christmassy vibes around you? Did you do anything? See, it's all a season of celebration, of lights, of good vibes, of so much just joy around, isn't it? Yes? Are you feeling that? It's just such positivity around during this entire season, and that is why I wanted to make sure I have to take a session today. I just have to take a session. I have so much joy inside me that I really want to transfer it to my students today, and of course, what better than calculus could do so? Happy Christmas, Naresh, Priyanshu, Aswitha, everybody. Thank you so much and welcome to the class. Welcome to the class. Very Merry Christmas to each one of you. You know, this season, as I said, is a season of magic. It's a season of happiness, it's a season of positivity, and it's a season of self-belief, isn't it? And that's what Christmas stands for. So every late night session that you sit for, every question that you solve, every mock test that you sit for, every grinding that's happening, all the grilling that's happening, your preparation grilling, all of that is a part of your story of success, isn't it? Every little hurdle that you are facing along the way of your preparation, don't you feel it's a part of my story? It's like one chapter of my entire book of preparation for this giant exam like JEE. Isn't it? Don't you feel that? That every day is like a chapter. Some days something goes good, some days something goes bad. Some days we are studying and when you're solving questions, it's striking. Wow, and that day is just so good. That day is just so good. And some days you've studied so much, but somehow body is not aligned or memory is not aligned or sometimes the mood is not aligned. Sometimes your energies are not aligned. And that is why even when you know something, you're not able to reproduce it in the mock paper. And that really disappoints, isn't it? Some days you're feeling super high on zeal. Some days you're like close to, low on energy. Very weak, very lethargic, very fatigued. Yes or no? Yes or no? But all of this, trust me, when you look at it from bird's eye view, from a satellite perspective, satellite viewpoint, all this is a part of your story of success, isn't it? Yes or no? Later on, when you will see all of this in retrospect, when you'll try to recollect, oh, all these types of days had come, some days were so good, some days were so bad, it was such a challenging, such an up and down, such a roller coaster preparation journey. Don't you think it'll all feel like it was all worth it, yeah? In January, when you crack your JEE Main exam and it goes excellently well, and when you're sitting in your dream college, just sitting and trying to think, oh my God, I've gone through really so much to come here. And all of that is going to seem worth it. Every day, every minute that you have grilled yourself, grinded literally, all of that is going to seem so worth it. Yes, and you'll be so proud of yourself, yeah. So proud of yourself. Yes or no? Yes? Yes? So, all of y'all, please remember this Christmas season, New Year season, all these days are full of positivity, full of joy. So, whoever you come across, spread that joy out to them. Whatever happens in your day, always remember you have to end with a smile. Just remember this mantra for life. No matter what happens, have a smile. Unnecessarily start smiling and you will automatically start feeling good. Trust me. So in this entire magical season, I want all of y'all to promise me that yes, ma'am, no matter how the day goes, this is one chapter of my life. I will not concentrate on that day. Rather, I will look at it from a bigger lens, from a zoom out version. And I'll try to understand that this is just one day, this is one chapter. My entire book though is left, no? Every day I'm going to complete my chapter. I'll live that chapter, and one day I'm going to reach my dream college, crack that exam with a handsome percentile, and then I'll look back. On that note, let me smile and sleep. Let me smile and sleep. Yeah? Yes? Okay? Alrighty, folks. So on this note, let's go. I have calculus on the plate today. You already know calculus is one of the highest weightage units in your mathematics syllabus. Not just in your syllabus, but even with respect to your JEE Main exam, calculus happens to be very high weightage and very promising, and literally something which challenges you. From a question and concept perspective, calculus is literally something which challenges you. It will challenge you from conceptual clarity point of view. It will challenge you from visualization point of view. It will challenge you from recalling point of view. So it will challenge you on multiple levels. So if you attend this session from start to finish, trust me, you are going to polish your preparation and make it so shiny. This session is like a polishing on your calculus preparation and making it absolutely shiny, like spick and span shiny. Okay, so today every question that we will solve is going to be like unwrapping a present. All of us like Christmas presents, yes or no? Did anybody of you get a present, by the way? Did anybody of you get a present? Hi Anushri, so good to see you. Did anybody of you get a present, or did anybody of you give a present to someone? Anybody? Yes? See, if you have or if you haven't, every question today will be like unwrapping a present. And all the presents that we will unwrap will actually lead us to the very big gift, which is mastery in calculus. And that is the biggest gift that Santa has come to give you today. But in order to get to that gift, which is the big gift of calculus mastery, I want all of you all to treat every question like unwrapping a small present, tiny present, that little happiness, which takes us to the big happiness. Yes? All right. Is that cool? Is that cool? So you're going to be on the same page. We're going to make this Christmas count. C for Christmas, C for calculus. Are we going to make this Christmas count? Are you ready to open the calculus presents? Every question is a present, I told you. Are you ready to unwrap and open the presents of calculus? What Santa has for you? Okay, is that cool? Now, please listen to me. Everyone, first of all, mark your attendance by hitting the like button. That is non-negotiable. And also, you have to subscribe to the channel if you have not done that yet. Fatafat se, ekdam, tezi se. Okay, and also one more thing I wanted to tell you, that calculus I have divided into two parts, differential and integral. I didn't want to rush you through the session of every type of calculus question from both the parts, which is differential and integral. So this session is going to be all about differential calculus, and of course I'll be coming up with another session for integral calculus. All right? All right, don't worry about BitSat. 100%. Please be completely carefree. Okay, you can rely completely upon us. We're going to take care of you. But right now, one thing at a time, let's focus on today. Let's focus on right now with a lot of happy Christmassy, joyful vibes. Can I get started, everybody? Duration is going to be around 2 to 3 hours, somewhere that time. But let's make every second count. Let's open every present and share with each other how did we feel with that present. All right, all the questions are the presents for you. Let's dive into the first question, which is the first calculus present. On your marks, get set, go. First question on your screen, everybody take a look. F of cot x is sine 2x plus cos 2x. Let f be a function defined on the set of real numbers R, taking the values in R and satisfying the above condition for x belonging to 0 to pi. What is f dash 2? What is f dash 2? Quick. What is f dash 2? Now, questions are going to be mixed. I have many PYQs. I have many new questions, challenging questions, easy questions. It's all variety, as I've already told you. I will be covering up major varieties which are NTA favorites and which you must master if you are really serious to ace your January attempt. Okay. So every time I have not written that it's a PYQ, but many questions are PYQs for mains and advanced, and many are new questions as well. So let's go. Getting RHS in terms of cot and replacing cot x with y. Wow. Ma'am, please tell the concept. हाँ तो first you brainstorm, no Anushri? First you brainstorm. That should work. Let me see. It's saying f of cot x is equal to sin 2x plus cos 2x. What Priyanshu is suggesting is that, ma'am, you express the right hand side, this is your right hand side, you express in terms of cot x. You express your right hand side in terms of cot x. Why? Because f is a function of cot x. So when f is a function of cot x and you will express your right hand side in terms of cot x, then what Priyanshu is saying is, ma'am, then you replace cot x with y and you will get a proper, well-defined, a very standard looking definition of f, which is very good. And then in the place of input, you can plug in 2 because I want f dash 2. Do you think that's going to work? You want to try it out? Let's try out Priyanshu's approach, okay? So sin 2x is 2 tan x upon, tell me quickly, what is sin 2x? 2 tan x upon 1 minus tan square x. Quick guys, Priyanshu has given us an idea. I think Aswita is also, okay with the same idea, yes? Okay. So 2 tan x upon 1 plus tan square x plus 1 minus tan square x upon 1 plus tan square x. Now I want you to understand, I want to convert things in terms of cot. So what will I do? Divide up and down by tan square. So I will get 2 tan upon tan square, 1 tan cancels. You get 2 into 1 upon tan, which gives you 2 cot x. Upon 1 upon tan square gives you cot square, and tan square upon tan square gives you 1. Plus, this is what? Cot square x minus 1 upon cot square x plus 1. Now listen to me carefully. What does this become? 2 cot x plus cot square x minus 1 upon 1 plus cot square x. Yes or no? This is what I am getting. Very good, Himanshu, very good. This is what I am getting. So in a way, I have written my right hand side in terms of cot, isn't it? F of cot x is equal to, what is it? Cot square x plus 2 cot x, cot square x plus 2 cot x minus 1 upon 1 plus cot square x. Can you tell me what is the range of the cot function? Everybody? Shazayan, around 2.5 hours. Can you tell me what is the range of the cot function? What is the range of the cot function? This is how it looks like. This is 0, this is pi, and so on. The branches keep on continuing. Yes, it's a periodic function with period pi. Yes, Naresh, it's set of all reals. Himanshu, set of all reals. Very good. Now, you know, if my cortex is actually coming from set of all reals, I can replace cortex with y. What's the problem? I'm going to get f of y is equal to y square plus 2y minus 1 upon 1 plus y square, where your y is coming from set of all reals as suggested by the question, that your input has to vary over the set of all reals. Yes or no? Yes or no? F is defined on the set of reals. No, because f is defined for cortex. And if x is coming from 0 to pi, you can see in the diagram, if x is coming from 0 to pi, cortex is coming from entire real line. No, that means f of real is what is given to you. So f of y, where y is real, is something which is the correct interpretation. Galti se domain likh diya. No, Priyanshu, cot, range of cot. Domain is set of all reals minus all the integral multiples of pi. Range you've written right, no, set of all reals. Okay. Now what? I want f dash 2. Very good. Compute f dash y. Second function, differentiation of first minus first, differentiation of second, whole upon second, whole square. So f dash 2, what is the value? 2 square is 4. 4 plus 1, 5. 5 into 2 2s are 4. 4 plus 2, 6. Minus 4 plus 4, 8. 8 minus 1, 7 into 4. Whole upon 4 plus 1, 5 square, 25. So 30 minus 28 upon 25, which is 2 upon 25. Can you tell me, is this correct? Are you getting the same answer? See, this question was not a very difficult question, trust me. Imandari se, very honestly, put your hand on your heart and tell me, was it a very difficult question? Was it a very difficult question? No, right? But the approach is what I want you to take away from here. This question did not give you a standard definition of f of x equal to, f of y equal to. No, it gave you f of cot x equal to. In any such situation, please remember what Priyanshu suggested was bang on, spot on, nail on the head, correct. Absolutely correct. Very good, Priyanshu, proud of you. He said that on the right hand side, you express the expression in terms of cot x because my f is defined over cot x. And then eventually replace cot x with any dummy variable and you will have a proper, well-defined, standard-looking definition of f that we were searching for. Because until and unless we don't have a standard definition of f, we can't differentiate and we can't find f dash 2, right? That's the flow, na? That's the flow. I want f dash 2. For that, I want f dash x. For that, I want f of x. But how will I get f of x or f of y? Did you understand? Yes? Is this question hashtag HDCC? You unwrapped this present. Did you like it? Is there a smile on your face? Is there a smile on your face, everyone? The first present, did you like it? Because I'm going to start throwing another present on you. I want a smiley from each one of you in the chat. First question is a present. Did you like it? Did you like it? Yes? Yes, Naresh. Yes, Priyanshu. Yes, Himanshu. Yes, Anushri. Entire differential calculus, Anushri. Entire differential calculus. Okay? Yup. Alrighty then, everyone. Please brace yourself for the next question. Brilliant question. I want you to brainstorm, and more than brainstorm, I want you to visualize. This is the next present, and very nice present. I'm sure you'll like it. The maximum value of k for which sin x plus 2x is greater than or equal to k times x into x plus 1 for all x coming from closed 0, pi by 2. Try it out, try it out, try it out. Please try it out. No hurry, no pressure. Maximum value of k for which my left hand side is greater than or equal to the right hand side. You have to suggest that value of k for which my left hand side function is at least my right hand side function. Somebody is suggesting graph. X is positive, so we can take 2x on the other side. Okay. Works. Works. But right hand side looks like a standard known function, isn't it? Your right hand side looks like a standard known function. What is that known function? K times x into x plus 1. That means k times x square plus x. Yes, x square plus x stands for what? Parabola. So right hand side is a very much known standard function whose graph we are very comfortable plotting. It's a parabola. Yes or no? What about the left hand side? Because right hand side right now is a standard function whose graph we know is a parabola, don't disturb it. No, don't disturb it. Don't try to complicate it by taking 2x on the other side. Don't complicate it. Right hand side is a very neat, very familiar function which is known to us, whose graph is known to us. So don't disturb its standardness. Okay? Don't disturb its standardness. What is this? This is a parabola. So when you bring 2x to the other side, you're kind of disturbing the setup of the right hand side. So don't do that. Understood why I'm saying? But again, the approach of graph is what is going to save you. Very good, very good. Think of another approach, but I wish to tell you that graphical approach is what is going to, trust me, save you in any question which comes like this. Today I've brought for you varieties of questions. Every variety has its own algorithm. If you get any question like this, today you will get to know what approach to follow, foolproof approach to follow. Okay, like here, if I talk about sin x plus 2x, let me take this as f of x, okay? Understand the pedagogy, understand the flow. I don't know what the graph of sin x plus 2x looks like. Of course, I'm going to plot its graph. To plot its graph, I will use the tool of application of derivative. So I have f dash x with me, which is cos x plus 2. I know as a matter of fact that cos x plus 2 is positive for every x real. I am only interested in 0 comma pi by 2 interval, but I know as a matter of fact that it is positive for every x real. If f dash is positive, this implies f is strictly increasing on the entire real line. If on the entire real line it's strictly increasing, obviously on 0 comma pi by 2 also it will strictly increase. Yes or no? This implies f will also strictly increase on 0 comma pi by 2 closed interval. Yes, it's strictly increasing. Now, listen to me carefully. Okay. In 0 comma pi by 2, the interval is closed 0 comma pi by 2. Please tell me what is f of 0? It is 0. What is f of pi by 2? Tell me sin 90 is 1, 1 plus 2 pi by 2, which gives you pi plus 1. It's greater than 4. 3.14 plus 1 gives you 4.14, right? So it's greater than 4. Here somewhere, let's say is 4. Here is 0. Your graph looks like this. This is your pi by 2. Any confusion, anyone? I have made a rough sketch of sin x plus 2x. It's a strictly increasing function in 0 comma pi by 2 ranging from 0 to 1 plus pi. 0 to 1 plus pi. Cool. This is clear. Now let's attack the right hand side. See, what is my right hand side? Let's say its name is g of x. It's kx into x plus 1, which means k times x square plus x. You know, if I talk about x square plus x, trust me folks, this is very simple. If I talk about x square plus x, x common x plus 1. So its zeros are what? 0 and minus 1. And it's an upward opening parabola. Yes or no, people? Yes or no? The leading coefficient is 1, which is positive. It's an upward opening parabola. Intersecting the x-axis at two distinct points, 0 and minus 1. Correct? Clear? Cool? Right? HDCC? Wait, perfect. Right? That means ideally, what will this look like? What will this ideally look like? Ideally, this will look like this. Ideally, it will look like this. This is minus 1 and this is 0. Yes or no? Yes or no? Right now, we are not talking about k. Right now, we are talking about x square plus x. And if I want maximum value of k, I would want k to be positive only, no? Yes or no? Right? I would want k to be positive only, no? Now, this is how my x square plus x looks like. 1 times x square plus x. Tell me, corresponding to k positive also, it will look the same. It will again cut minus 1 and 0, cut the x-axis at minus 1 and 0. It will again be upward opening for k positive. These two features will continue to follow. Yes or no? And now, what will it look like? It can look like this. Please look here on the diagram. It can look like this, or it can look like this. Can you see all the possible upward opening parabolas I'm drawing corresponding to different Ks? Yes, I've drawn that, Priyanshu, intersecting at two distinct points. Or let me take another color. Or it will look like this. If you look at the white parabola, please listen to me carefully. It's a very beautiful analytical question, very conceptual, very analytical, and very easy also. If you look at the white parabola, you remember the yellow curve, right? Yellow curve is my curve. Yellow curve is actually my curve. This is my actual curve. Yes? If you look at the white parabola is above the yellow curve. White parabola is above the yellow curve. White parabola is above the yellow curve. That means my right hand side function is greater than my left hand side function. I don't want this. I don't want such a parabola whose branch is above my sin x plus 2x function, because I want sin x plus 2x to be greater than the right hand side. No, I don't want my parabola to be greater than the sin plus 2x function. So white wala parabola to can't be there by. No, this can't be there. What about the blue parabola? Can that be there? White to can't be there, you understood? Can blue be there? Can blue be one of the correct parabolas? Acceptable parabolas? No, because in entire 0, pi by 2 interval, I want my sin x plus 2x to be greater. And in the blue parabola scene, you can see that from 0 till this value, say x, from 0 to x, yellow is above blue. But after x, blue is above yellow. Arey Baba, I throughout want yellow to be above blue, no? I throughout want yellow to be above blue. But from 0 to x, yellow is above blue. But after x, blue is above yellow. No. That scene is not permissible. Because in entire interval 0, pi by 2, I want my yellow to be above blue. I want my yellow to be, yes, very good. I want my yellow to be above blue. So the blue one is also cancelled out. Perfect. That means now I'm only left with the red one. And within the red one also there is a catch. Within the red one also there is a catch. There are two possibilities, everybody. There are two possibilities. See, listen to me carefully. The root of my parabola is -1 and 0. So it will pass through 0. So 0 is a common intersection point for both my left hand side and right hand side functions for sure. No matter what k is, 0 is one of the intersection points. If I attach the condition that, this is my g of x, right? That my g of pi by 2 is less than f of pi by 2, or g of pi by 2 is equal to f of pi by 2. Right hand side function is g, left hand side function is f. Remember, right? This is your g and this is your f. Yes? Okay, if I say that my, what? If I say that my red parabola is throughout 0, pi by 2 interval below the yellow graph. Throughout 0, pi by 2 interval, if red is below yellow, to ensure that I have to attach either of the two conditions. Either g of pi by 2 can be actually equal to f of pi by 2. In that case also my red graph will be below the yellow graph. Yes? Or my g of pi by 2 can be strictly less than f of pi by 2. Even then, throughout the interval, my red graph will be below the yellow graph. Because it's greater than equal to. It's greater than equal to. So I am allowed to match the answers at pi by 2 also. G of pi by 2 equal to f of pi by 2, that can also work. So if I just attach this condition, this or this, it will make sure for me that my red curve is always below the yellow curve. Is this making sense to you? Is this making sense to you? Huh? Because see, when you have differentiated your f dash, no, one more thing you can check, compute f double dash. If you compute f double dash, you will get minus sin x, right? Which is clearly negative. That means f is concave downward. F is concave downward. So your yellow graph is concave downward. Your red curve is an upward opening parabola. It's throughout concave upward. So it's a downward graph. Then here is an upward graph. If I want this upward graph to be throughout below the concave downward graph, I just need to catch hold of the of the extreme points of my interval 0 and pi by 2. At 0, though I know both are coinciding. At pi by 2, if the value of red curve is below or equal to the value of the yellow curve, condition satisfied. Condition satisfied. Is that making sense? So I just need to solve what? The condition that my g of pi by 2 is less than equal to f of pi by 2. G of pi by 2 means k times pi by 2. Pi by 2 plus 1 is less than equal to f of pi by 2. Sine 90 is 1 plus pi. Correct? So k pi by 2, this is 2 plus pi whole upon 2 less than equal to 1 plus pi. So you have k pi 2 plus pi less than equal to 4 times 1 plus pi. So your k is less than equal to 4 times 1 plus pi upon pi times 2 plus pi. The maximum value of k is at least this, k is at max this much. This statement means what? K is at most equal to the quantity 4 times 1 plus pi upon pi times 2 plus pi. This is the maximum value of k. Very, very good. Very, very good. Ansh, it's okay now that you've come. Make sure that you attend the class with full sincerity, okay? 1 second. All right. No, it's differential calculus today, not integral calculus today. Is this clear, everybody? Please tell me if there's any confusion. I'll quickly help you understand this again. Hi, Sasha. Everything? Hashtag HDCC, everybody. Completely clear. Whenever you get a question like this, you know how you have to visualize. How did we imagine 3 scenarios, but actually 2 of them did not work out. Remember the white parabola and the blue parabola? Only the red parabola worked out, right? Only the red parabola worked out, and that actually is the magic. If that much you're able to visualize, this question is a cakewalk. Have you understood? Yes or no? We had left hand side function, which is f of x, right hand side function g of x. I wanted to show f is greater than or equal to g. That means geometrically what this means? Graph of f is above than graph of g. Where? In my interval 0, pi by 2. So I drew the graph of f using the application of derivative concept. It was strictly increasing. It was 0 at 0. It was 1 plus pi at pi by 2. And it was concave down. I drew the yellow curve, which is my left hand side function, f of x. Now my right hand side is a parabola. So I drew it, but I drew 3-4 versions of it. And I realized that if I want my red curve to be below the yellow curve, only this version is going to satisfy that. And this version comes into picture under what condition? Under what condition? That g of pi by 2 is either less than f of pi by 2 or g of pi by 2 is equal to f of pi by 2. Second present was wonderful. Awesome, awesome. Unwrapping the second present was wonderful for you. Great to know that. Are you all ready to move on to the third question? Make a smiley. We're going to end every question with a beautiful smiley. Everybody, ready for the third question? Ready for the third question? Brace yourself quickly. Okay, this is the right answer, B, right? Very, very good. Very, very good. No, Atreya. It's a mixture of PYQs from mains, from advanced, as well as some new questions which are really challenging. But the idea is that you take away the concept from every question. And I want you to rack your brain on every question. Every question is like a present, right? You remember I used to I gifted one of my friend a present which I packed with 5 or 6 gift traps. So one open, then another open, then another open, then another open, then another open. So she was tired when she actually reached the gift. This was something I have done very many times. So it's like that. In order to unpack or unwrap a present, which is a question, you have to rack your brain and try to decode what the question says. Yup. Let's go. Let's go to question number 3. This is fantastic. I want you to please tell me, how will you crack this? It's a one-liner question. And this, trust me, it's a 99.99 percentile question. If you are able to solve this, kudos. Literally kudos to you. What does it say? F is given to you. Does it have a local min at 1 or local max at 1 or no local extrema at 1 or none of the above? Who knows? Tell me. Nitish, this is differential calculus. Integral calculus will be coming after a couple of days. Isn't the quadratic positive? Tell me. What do you think? Even if it's positive or not, there is a mod around quadratic, right? Huh? Quick. 1 is the point. Look at the options. No need to brainstorm upon any other point on the real line. Only brainstorm upon x equal to 1. What is that for my function? What is x equal to 1 for my function? Anybody? I'll write f of x minus 1 mod of x square minus 2007 x plus 2010 plus sine of x minus 1 into log x. A is the right answer. Who said A? Okay. Very good. This is a beautiful observation, everybody. Beautiful observation. 1 is a point on which I want to examine my function's behavior. And what I'm able to see is that f of 1 clearly is 0. F of 1 to is pakka 0. F of 1 is pakka 0. Now there are 3 scenarios which arise. If f of 1 is 0, listen to me carefully. This is how you have to think in all directions. It's JEE Main, for God's sake. Yes, can't take it lightly. When you say f of 1 is 0, there are 3 situations which arise. This is 1. Listen to me carefully. If you want 1 to be a point of minima, that means before 1 the graph should decrease and after 1 the graph should increase. Keeping in mind that at 1 function's value is 0, so it will touch the x-axis. That means the only possibility is graph goes something like this. In this situation, x equals 1 is the point of minima. When is it the point of minima? When right before 1, when in the immediate neighborhood of 1, 1 is the least value. That means in mathematical language, f of 1 minus is positive and f of 1 plus is also positive. From the neighborhood, you pick up inputs which are immediately less than 1 and the value of the function is positive. And then you pick up inputs which are immediately greater than 1, very close to 1, the value of the function is positive. Himanshu is going with C. Okay. Yes. Another scenario occurs when you say that 1 is the point of maxima. Point of maxima means before 1 graph is increasing, after 1 graph is decreasing. And at 1 function's value is 0. So this is how it will look like. Yes or no? This is the only option. Priyanshu is going with A. This is the only option, no? Yes or no? This is the only option, right? In this case, x equals 1 is point of maxima. Perfect. Anushri is also saying A. Okay. Okay. That means f of 1 minus is negative and f of 1 plus is also negative. Oh, and what if 1 is neither a point of max nor a point of min? See, in the first scenario, your f is throughout above the x-axis. In the second case, your f is throughout below the x-axis. But in the third case, when 1 is neither a point of max nor a point of min, graph can go from bottom to top or can come from top to bottom. In this case, x equals 1 is neither point of max nor a point of min. How many of you all have understood this? And in this case, mathematically, I can say f of 1 minus is negative and f of 1 plus is positive. Or it can be vice versa. The graph can go from top to bottom. F of 1 minus will be positive, f of 1 plus will be negative. Basically, f of 1 minus and f of 1 plus will have opposite signs, when one is neither a point of max nor a point of min. Is this clear? Look at the options clearly. Has this much entered your head? That when I say x equals 1 is a point of max, what do I mean? Which figure I have to imagine? When I say x equals 1 is a point of min, this is what I have to imagine. This is for max, this is for min. And this is when it's neither max nor min. So before 1 and after 1, if the derivative or rather function's value is positive, it is minima. Before 1 and after 1, if the function's value is negative, it is maxima. And before 1 and after 1, if the function's value is positive then negative or negative then positive, that means it's neither max nor min. Shri Varshan is going with B. So much variation. All right. Priyanshu has now opted for C. All right. Vijay. C. Okay. Athreya, D. Look at this. In front of every option I have names. Okay. Okay. Now let's go. If you have understood this analysis is not just restricted to this question. I hope you visualized what actually does this mean in terms of any question which comes your way. Alright. Now let's start. F of 1 plus. F of 1 plus, when your input x is greater than 1. This means when x is greater than 1. Immediately greater than 1. Very, very close to 1 but greater than 1. This is going to be positive. No doubt whatever this value is, its mod is going to be pakka se positive. Sign of a very small positive quantity. Positive. And logs graph, you remember, right? Log graph. This is 1. If you are very, very close to 1 but greater than 1, then again log is also positive. So everything positive, that means this is certainly positive. F of 1 plus is pakka positive. Now let's see what is f of 1 minus. That means when your input is less than 1. Who will tell me? Who will tell me? Tell me. What about f of 1 minus? Himanshu says it's negative. Yes. Why? Because I'll just quickly write this. See, x minus 1 mod of x square minus 2007x plus 2010 plus sine of x minus 1 into log x. Listen to me carefully. When x is very, very close to 1 but to the left of 1, this is a negative fraction. Yes or no? It's a negative fraction. Now you are squaring a fraction. If you are very, very close to 1 but to the left of 1, you can say that you are in between 0 and 1. So you're picking up a fraction. X is basically a fraction. You are squaring it. Minus 2007 times that fraction plus 2010. So it's a very big positive number. It's a very big, relevantly, significantly big positive number. And you are multiplying it with a very small negative quantity. That means this entirely is minus of a big number. Are you able to make sense of this? The mod quantity is a big positive number and x minus 1 is a negative fraction. So you are multiplying it with a big positive quantity. So you are getting this very big, very good Priyanshu, very big negative number. Yes. What about this? Tell me. When your input is lying between 0 and 1, what happens? When your input is lying between 0 and 1, what happens? When x is between 0 and 1, that means x minus 1 is negative, lying between minus 1 and 0. See na, if x is between 0 and 1, then x minus 1 is between minus 1 and 0. And between minus 1 and 0, if your input is there, sign is going to give you negative answer. So this is going to be negative fraction. Similarly, if your input is between 0 and 1, even log is going to give you a negative fraction as the answer. Yes or no? That means negative into negative. This is a positive but a very small fractional quantity. Very small. Negative into negative is pakka positive, but it's a very small positive fractional quantity. So minus of a big number plus a positive fraction. Yes, 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 that means f of 1 minus is certainly going to be negative. Any confusion, anyone? Not that difficult, but this was the analysis required in this question. F of 1 plus is positive was very simple to identify, but f of 1 minus, what will this be? This was a tricky area, a slippery area, a complicated part. And it's coming out to be negative. So after 1, function is giving positive value. Before 1, function is giving negative value. You can see it's like this. After 1, function is giving positive answer. Before 1, function is giving negative answer. It's the third scenario. It's the third scenario, which means 1 is neither a point of max nor a point of min. Neither a point of max nor a point of min. C is the right answer. Lakshita understood? A is wrong, B is wrong, D is wrong. Sasha wrong, Anushri wrong, Varshan wrong, Athreya wrong, only Himanshu, Vijay and Priyanshu correct. Priyanshu, even you said A in the first go, but I hope you know C is correct. You understood, right? Understood this question? 99.99 percentile, guys. Is the approach clear? The concept, the fundamentals are clear? Question was of one line where only functions definition was given. But look at the analysis, how much analysis I've done for you. How much analysis I've done for you. So that in any other question also, if something like this pops up, you know what does it mean. Either of the 3 scenarios will hold true. And once you have visualized that when a function is having local max at 1, when a function looks like something which has local min at 1, when a function looks like something which has neither a max nor a min at 1, how does it look like? When you know how does it look like, it's very simple for you to mathematically then justify your argument. It becomes very simple. Is that clear? Very, very, very important question. Please make a star. If you liked unwrapping this present also, let me know in the comments below. What is the answer? What is the answer? This has no local max or local min at 1. 1 is neither a point of max nor a point of min. Okay? Not A, Anushri. The answer is C, not A. Everybody ready for the next question? Hashtag HDCC from each one of you in the chat. All questions have to be internalized by you. These questions are not just these questions. If you're down with 3 questions till now, trust me, varieties have been covered. If you look at the PYQs, questions like these will be plenty. So actually, technically you have solved 3 questions, but volume wise, you have covered more than 30 questions. Okay, are you understanding? That is why these varieties are so rich, which I bring for you. Let's go. Beautiful, wonderful. This is a JEE Main PYQ. This is a JEE Main PYQ. If you all have solved it, great. If not, solve it with me. And if you have also solved it before, again solve it with me. It's that important. It's that important. F is given to you, which has GIF function involved, one of the favorite functions of NTA. If M is the number of points where F is not continuous or discontinuous, N is the number of points where F is not differentiable, what is M comma N? Time for another present. Today Santa is very happy. He's giving you a lot of presents. This is the 4th present. Graph. Okay. Okay. Tell me. X is coming from -2, -1. This is mod x less than 1 and then otherwise. How can you break the function into a piecewise function properly? It is defined piecewise for you, but how can you simplify it even further? That is a journey which you have to travel. How will you simplify it even further? Try it out. Not that difficult. Not that difficult. Anybody? Let's try to simplify F. See, when you say x belongs to minus 2 comma minus 1, this implies GIF of x pakka says minus 2. This much is sure. So when you're writing f of x, you write sine of x minus, or rather x plus 2 upon x plus 2. Is this part clear? When x is sandwiched between minus 2 and minus 1. Because when x is sandwiched between minus 2 and minus 1, what happens? What happens? GIF of x is minus 2. So this is what your function's definition becomes, which is now free from GIF. Now our definition is free from GIF. Okay. Next is max of 2x and 3 times GIF of mod x. GIF of mod x. When mod x is less than 1. Okay. When mod x is less than 1, this implies what? Mod x I know is greater than or equal to 0, and additionally it's given to be less than 1. When something is sandwiched between 0 and 1, its GIF is 0. So GIF of my mod x, GIF of mod x will be 0, and 3 into 0 is 0. 3 into 0 is 0. So this happens when mod x is less than 1. That means x is sandwiched between minus 1 and 1. And it is 1 otherwise. Is the simplification clear? Is the simplification clear? When mod x is between 0 and 1, its GIF is going to be 0. So 3 times 0 has given you 0. But let's analyze the maximum part. This says minus 1 to 1. So this is minus 1, this is 1. You draw the graph. You draw the graph. This is your 0 graph, and this is your y equal to 2x graph. You have a 0 graph, y equal to 0, which is the horizontal line coinciding with x-axis between minus 1 and 1 is your y equal to 2x. Maximum means above. So from minus 1 to 0, this is above. And from 0 to 1, this is above. Yes or no? From minus 1 to 0, y equal to 0 is on top. And from 0 to 1, y equal to 2x is on top. Can you see this? Can you see this? So I can in a way write that when x is sandwiched between minus 1 and 0, the maximum is 0. And when x is sandwiched between 0 and 1, the maximum is 2x. And otherwise everywhere, it's 1. How many of you all have understood this? How many of you all have understood this? Please tell me. I have completely simplified my original given function. There is no GIF, there is no mod, there is no max. Everything is simplified. I've broken it down in the maximum level possible. If there is any doubt, any confusion, any iffiness, stop me right now and ask me right now. I'm looking at the chat. Is that cool? Because now I'm going to get started. When you say otherwise, this is something which is the trickiest part of this function, of this question. See, there's one more way in which I can write this. See, when x is sandwiched between minus 2 and minus 1, what is it? Sine of x plus 2. Keep looking upon x plus 2. When x is between, this is minus 1. Between minus 1 and 0, this is 0. When x is lying between 0 and 1, this is 2x. When x is greater than or equal to 1, this is 1. When x is less than or equal to minus 2, again this is 1. This is what otherwise means. This is what otherwise means. When things are equal to and less than minus 2, the answer is 1. When things are beyond 1, the answer is 1. Yes, the simplification is done completely now. Is this completely understood? Many times students take this otherwise for granted and they don't know that actually function is defined beyond 1 also. Function is defined before minus 2 also. Now that I have the definition corresponding to every part of my real line, now I can get started. See, before minus 2, it's a constant function, continuous and differentiable. Between minus 2 and minus 1, of course, this is also continuous and differentiable. Quotient of two continuous functions, continuous. Quotient of two differentiable functions, differentiable. Between -1 and 0, again, constant function, continuous differentiable. Between 0 and 1, it's a polynomial function, continuous and differentiable. After 1, it's a constant function, continuous and differentiable. So very good. Very good. What are my problematic areas? Problematic areas are the connecting points. -2, -1, 0 and 1. -2, -1, 0 and 1. Let's check at -1. Let's start with -1. Listen to me. Let's start at -1. Left hand limit. What will this be equal to? Limit x tends to -1 from the negative. Sine of x plus 2 upon x plus 2. So 2 minus 1 is 1. This is giving you sine 1. What about the right hand limit? Limit x tends to -1 from the positive 0. This is 0. Sine 1 is not equal to 0. So at -1 function is discontinuous. So points of discontinuity. -1. Let's check if there are other points. -1 is done. It's discontinuous. That means here the function is not differentiable also. Discontinuous implies not differentiable. Correct. Now let's move towards 0. At 0, what is left hand limit? Left hand limit is 0, you can see. And right hand limit? Right hand limit is again 0, you can see. 2 into 0 is 0. 2 into 0 is 0. Yes. What about 1? At 1, your left hand limit is equal to 2 into 1, 2. And your right hand limit is equal to 1. Oh my God. Oh my God. Tell me. Tell me. So at -1 it was discontinuous, that means not differentiable. At 0 it was continuous, but I don't know if it is differentiable or not because continuity doesn't imply differentiability. Yes, at 1 it was again discontinuous, so non-differentiable. So I have till now got 2 points of non-differentiability. I also have to check at -2. I also have to check at -2. At -2 what's happening? See. Left hand limit. Left hand limit is 1 less than -2. Right hand limit is what? Limit x tends to -2 from the positive sine of x plus 2 upon x plus 2. What is this? Sine theta by theta when theta approaches 0. This is 1. And the value of the function -2 is also 1. That means continuous at -2. Similarly, continuous at 0. Continuous at -2, continuous at 0, discontinuous at -1 and 1. Discontinuous at -1 and 1. Is this clear? C is the right answer, Priyanshu says. Okay, anybody else? Okay, let's go. Now that I know points of discontinuity are 2. Achha, Himanshu is going with B. And you can't change your option now, okay? Shrey Varshan. Again. Vincent, today is differential calculus. After this, I'll do integral calculus, okay? Tell me, 2 points of discontinuity. Please tell me. Points of discontinuity. So m is pakka se equal to 2. What about points of non-differentiability? If a function is discontinuous at an input, it is obviously not differentiable at that input. So at -1 and 1, it's not differentiable also. Now we are left with 2 points to check. One is -2, one is 0. One is -2, one is 0. If I compute f dash x, I will get 0 when x is less than equal to -2. Then sine of x plus 2 upon x plus 2, right? So second function, differentiation of first minus first, differentiation of second upon second whole square. This is when x is lying between -2 and -1. Next, 0, differentiation is 0 between -1 and 0. Next, 2x, the differentiation is 2 when this is between 0 and 1. And it's again 0, differentiation, okay, when x is greater than or equal to 1. Now tell me, if you compute f-2 from the negative and f-2 from the positive, they will come out to be equal to 0. Limit of f-, not 2, -2. Limit of f- as x approaches -2 from the left and from the right, both will give you 0. So my f is differentiable at -2. But if I compute f-0 from the negative, 0 from the negative will give you 0 and f-0 from the positive will give you 2. They both are unequal. Left-hand derivative is not equal to right-hand derivative. Left-hand derivative is not equal to right-hand derivative. So f is not differentiable at 0. So apart from -1 and 1, 0 is also a point of non-differentiability. So my n is coming out to be equal to 3. Wow. I mean, wow. 2, 3 is the right answer, not 2, 4. Priyanshu, version is correct. Himanshu is correct. We had how many points to check? -2, -1, 0, 1. That's it. 4 points. -2, -1, 0 and 1. At -2, continuous. At -1, discontinuous and hence non-differentiable. At 0, continuous. At 1, discontinuous and hence non-differentiable. So points of discontinuity are only 2, which is -1 and 1. But points of differentiability, I have -1 and 1, but out of -2 and 0, I have to check. So -2, left-hand derivative and right-hand derivative came out to be equal, both equal to 0. But at 0, left-hand derivative came out to be 0, right-hand derivative came out to be 2, unequal. Unequal. Ma'am, there is no equality for -1. No, there is no equality for -1. Okay. Is this cool? Where is this? Where is the... Yes. At -1, as it is, it's not continuous, no? So why do you bother about the value of the function at -1? If suppose my left-hand limit at -1 would have been equal to right-hand limit at -1, but I don't have the value of the function at -1, then there would have been panga. Then there would have been panga. Because I can't talk about continuity of a function at a point until and unless the function is not defined at that point. Alright, is this question clear, everybody? Is this present nicely unwrapped and completely seen, enjoyed, thoroughly joyful from the present? Every bit of it, is it understood? This is not the explanation, whatever I'm giving you for every question is not confined to just one question. It's not confined to just one question. It's actually a concept that I'm sharing with you, and hence I want you to please take a note of it. Okay? Chalo then. 2, 3 is the right answer for this question. Moving on to the next one. Tell me, this is a JEE Advanced PYQ. This is based upon, again, a supremely important concept from differential calculus, which very few people are aware of. Very few. Trust me. Thank you so much. Means a lot. Vijay, around 10-12 questions. Okay? But they are all voluminous questions. So as I said, when I'm solving 4 questions with you, it's equivalent to solving 40 questions with you. So make sure you are understanding every bit of the explanation very nicely. It's a heavy session. It's not sabke bas ki baat. Trust me. So if you really are serious to up your game, stick till the end and extract as much as you can from the discussion. Okay, f of x is given to you. For x not equal to 1, obviously, limit x tends to 1 from the negative and 1 from the positive. This is not 0. Limit does not exist. Limit does not exist. Wow. Wow, Priyanshu. Wow. Very, very good. Because, why am I happy? Because when you say x tends to 1 from the positive. Okay. X tends to 1 from the positive. This means x is greater than 1. So, limit x tends to 1 from the positive, 1 minus x into 1 plus. How will mod of 1 minus x open? Mod of 1 minus x is nothing but 1 minus x when 1 minus x is non-negative or x is less than equal to 1, and it is x minus 1 when x is greater than 1. So when x is greater than 1, this is x minus 1. Oh, upon x minus 1 again, and this is cos of 1 upon 1 minus x. Perfect. Plus 1 minus 1 cancels out. You're left with 1 minus x square upon x minus 1 cos of 1 upon 1 minus x. Yes or no? Now 1 minus x square is minus of x square minus 1. This gives you x plus 1 into x minus 1 upon x minus 1 cos of 1 upon 1 minus x. Now x is approaching to 1. It's not equal to 1. It is very, very close to 1 but not equal to 1. So this is limit x tends to 1 from the positive, limit. Right? So you have minus of x plus 1 cos of 1 upon 1 minus x. Now listen to me very carefully. Very carefully. As x approaches to 1, x plus 1 approaches to 2. So this quantity is approaching to minus 2 cos of 1 upon 1 minus x. Now listen to me carefully. If x is approaching to 1, 1 minus x is approaching to 0. So 1 upon 1 minus x is approaching to infinity. Plus infinity, minus infinity, I don't care. But the input is approaching to infinity from either the right or the left. That means my cos is going to keep oscillating between minus 1, 1, minus 1, 1, minus 1, 1, minus 1, 1, minus 1, 1. As you are increasing your input, cos is continuing to oscillate between minus 1, 1, minus 1, 1, minus 1, 1. It is not converging at a certain value. It is not after a point in time limiting or approaching a certain fixed definitive value. It is continuing to oscillate between minus 1, 1, minus 1, 1, minus 1, 1, minus 1, 1. So this completely is oscillatory limit. Is oscillatory limit, or I can say this does not exist. DNE, this does not exist. As x approaches to 1 from the positive, this limit does not exist. So right hand limit does not exist. Right hand limit does not exist. It is not 0. It actually does not exist. Is this clear? It's not equal to 0. Very good, Himanshu. Very good, Rafia. It does not exist. What about the left hand limit? Tell me. Limit x tends to 1 from the negative, 1 minus x into 1 plus. If x is negative or less than 1, not negative, less than 1, this is 1 minus x. Okay, upon again 1 minus x, cos of 1 upon 1 minus x. So this is 1 minus x into 2 minus x upon 1 minus x. This, then I have 1 minus 2x plus x square upon 1 minus x, cos of 1 upon 1 minus x. This x square minus 2x plus 1. What is this? X square minus 2x plus 1 is x minus 1 whole square. This is what? X minus 1 whole square. Or you can write it as 1 minus x whole square. How does it matter? X minus 1 whole square or 1 minus x whole square, how does it matter? So this and this gets cancelled. You are left with 1 minus x into cos of 1 upon 1 minus x. Limit x tends to 1 from the negative. And now the magic starts, guys. Now the magic starts because this function, everybody listen to me carefully, a very important result, all your ears, eyes should pop open. This is a bounded function. This is a bounded function. If x approaches to 1, 1 minus x approaches 0, 1 upon 1 minus x approaches infinity. That is true. But input 1 upon 1 minus x is approaching to infinity. Throughout, it is obtaining real values only, na? 1 upon 1 minus x is real, na? And cos of any real angle is sandwiched between minus 1 and 1. Cos of any real angle is always sandwiched between minus 1 and 1. So this is definitely a bounded function. Pakka say this is a bounded function. And as x is approaching to 1, this is approaching to 0. Absolutely correct. Whenever, remember this magical concept. Please remember this magical concept. If you have a bounded function multiplied with a function, say g of x, which tends to 0, then this entirely tends to 0. Will you remember this? If you have a bounded function multiplied with another function which tends to 0, then this completely tends to 0. Will you remember this? So here I have a bounded function multiplied with 1 minus x which tends to 0. So this completely will tend to 0. The limit will be 0. The left hand limit is existing. The left hand limit is existing. It is existing. Right is not existing. Left is existing. So wonderful, yeah. So wonderful. You remember this result, right? The logic behind this concept is, suppose I have x cos x. Suppose I have x cos x. X is lying between minus 1, 1. Let's say. Now cos x is sandwiched between minus 1 and 1. Yes. Suppose I am saying x is positive. Just confined to 0 and 1. To explain you, multiply throughout by x. You will get minus x less than equal to x cos x less than equal to x. Now you know this tends to 0 as x tends to 0. This tends to 0 as x tends to 0. So using the sandwich theorem, x cos x also tends to 0 as x tends to 0. Okay. Similarly, if x was negative, same thing would have followed through. So always remember, if it was x square cos x, x cos x, or even if it would have been like this, x cos 1 by x. Again, cos 1 by x is sandwiched. It's a bounded function. So x cos 1 by x. Again, even this would have tended to 0 as x tends to 0. So you have to remember, alone cos 1 by x or cos 1 by x square, sin 1 by x or sin 1 by x square, these are all divergent functions. Their limit does not exist as x tends to 0, but x cos 1 by x or x cube sin 1 by x, these are all convergent, tending to 0. These are divergent, these are convergent, tending to 0. So a lot of learning from a single question. That's called exam-oriented preparation. When you're not solving random questions from any direction, when you're actually concentrating your efforts towards rewarding questions, promising questions, which actually give you a lot of takeaway. And in less time, it manages to teach you a lot of things. That is what is a perfect exam-oriented preparation. Hashtag HDCC. Everybody, so it was a multi-correct question, as I told you, JEE advanced level question. Left hand limit exists, but right hand limit does not exist. Very, very good, Priyanshu. Please, everybody, note down what Priyanshu has written in the chat. Everybody, if you have product of two functions, one is bounded, one tends to 0, then overall product tends to 0. Okay? Chalo. Come to this one. I am sure you would have seen this. It's a very, very, very important PYQ. And not just PYQ, that's why I have not written the year. I deliberately chose today to not write the year as to when this question was asked, if it's a PYQ, because I want you to take every question as a representative question of a certain variety. I don't want you to take this question as one question. Take this question as the representative of a complete variety of questions. This type of question, this variety of question has come in the paper multiple times now. So you have to understand what is the approach used. Question looks so good. Another, this present is wrapped in a very nice manner. Okay. All right. Tell me. How do you think you will start? Everybody, how do you think you will start? Okay. 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 Limit x tends to 0, 1 plus x square by 2 minus root over 1 plus alpha x square whole upon cos beta x minus e to the power x square, and then you have sine x square. There is one thing which I want you to catch hold of. Himanshu, you are bang on correct. Expansion is what this question is shouting out loud. Expansion. Either you use the LH rule or you use expansion, but here I feel expansion is what is shouting out loud, isn't it? Yes or no? It's shouting out loud. What do you think? What do you think I should do? The first step is something which should grab your attention. Tell me. Can you see sine of x square? If I divide by x square and multiply by x square, what do you think? Can I get rid of the trigonometric sine function? Very good, Vijay. Very good. Yes or no? X is approaching to 0. X square will also approach to 0. So sine x square upon x square will approach to 1. Oh. That means, tell me quickly, that means 1 plus x square by 2 minus root over 1 plus alpha x square upon x square multiplied with cos beta x minus e to the power x square. Yes, we've gotten rid of the sine function. As much as you can simplify, better it is. Now let's attack. What about cos beta x? Who will tell me the expansion? Cos x, 1 minus x square. So beta square x square. Tell me. By 2 factorial plus beta to the power 4 x to the power 4 by 4 factorial. Answer. Quick. Very good, Himanshu. Very good, Priyanshu. This is clear. This is cos beta x. What about e to the power x square? 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on. I want to perform the subtraction. Minus and so on. What will the subtraction look like? 1 minus 1 is 0. X square comes out common. You have 1 minus beta square by 2. Then x to the power 4 comes out common. This is minus 1. Okay, minus 1 minus beta square by 2. This is minus 1 by 2, or rather you can write this as beta to the power 4 by 4 factorial minus 1 by 2. Is this clear? I have done nothing, people. I have just subtracted both of them. Nothing major. Nothing great. Literally nothing out of the box. I've just done the subtraction. Okay? So what do you have in the denominator? Your denominator is quite ready. X square into x square multiplied with minus 1 minus beta square by 2. Minus 1 minus beta square by 2. Then you have plus x to the power 4. Listen to me carefully. Plus x to the power 4. Beta to the power 4 by 4 factorial. Minus 1 by 2 plus and so on. So listen to me. When you open this up, when you actually simplify, you plug in this x square inside and multiply with every term. What are you getting? You are getting x to the power 4 here and x to the power 6 here and so on. Correct? That means what is the minimum degree in the denominator? Tell me, what is the minimum degree in the denominator? What is written? What is the minimum degree in the denominator? If you have the denominator as x cube plus x to the power 4 plus x to the power 5 plus and so on, what do? You take out x to the power 3 common, 1 plus x square plus and so on. All these x's will tend to 0 and you will just be left with x cube. So denominator will get simplified. No, how will it get simplified? X to the power 4 common. You are left with minus 1 minus beta square by 2 plus x square times whatever plus whatever. All of this, because x tends to 0, all these terms will tend to 0. You will only be left with x to the power 4 into this quantity. How many of you all have understood this? How many of you all have understood this, that the denominator has been completely simplified? In such questions, always you want to catch hold of the minimum degree of the denominator. So I had one x square sitting outside. I opened this expansion up, okay, to till certain terms, 2-3 terms I opened it up, and then I multiplied x square with all the terms. I multiplied x square with all the terms of this expansion, and then I took out the what? Took out the minimum degree common, rest everything vanished. All positive powers of x went to 0. I am only left with this term. Yes? So this is my denominator. Numerator I still have to work upon, but my denominator is sorted. So whatever the numerator I don't care. My denominator is sorted, x to the power 4 minus 1 minus beta square by 2. Cool? Cool till here? Numerator. Let's catch hold of the numerator. It is 1 plus x square by 2 minus root over 1 plus alpha x square. Now 1 plus alpha square under root, that means it's power 1 by 2. What is this? 1 plus x square by 2 as it is? Minus. Tell me. Remember? Remember this? 1 plus x to the power n, where n is a fraction or a negative integer. What does this look like? Who will tell me? 1 plus nx plus n minus 1 by 2 x square plus and so on. Please tell me, is this understood or not? Remember binomial theorem for negative index or fractional index. Priyanshu, remember it very nicely and tell me, is this cool? So 1 plus alpha x square to the power 1 by 2 will be 1 plus 1 by 2 into alpha x square plus 1 by 2 into 1 by 2 minus 1 will give you minus 1 by 2 upon 2 into alpha x square whole square plus and so on. So you are getting minus 1 by 8. This is minus 1 by 8. Perfect. So you are getting 1 plus alpha x square by 2 minus 1 by 8 alpha square x to the power 4 and so on. Are you understanding? This is the concept part I am explaining. No, this is the chalo concept. This is concept part, which is binomial theorem for special or rather negative index. Right? Yes. So numerator is sorted. What is it? Write the numerator. 1 plus 1 and minus 1 gets cancelled out. Okay, fine. Cool. X square common 1 by 2 minus alpha by 2. So 1 minus alpha whole upon 2. Okay, fine. Minus 1 by 8 alpha square into x to the power 4 and so on. This is my numerator, everybody. This is my numerator. So I am saying x square into 1 minus alpha by 2 plus x to the power 4 multiplied with 1 by 8 alpha square, or rather alpha square by 8 with a minus sign, plus and so on. Whole upon, what was it? X to the power 4, and inside I had minus 1 minus beta square by 2. Minus 1 minus beta square by 2, limit x tends to 0. Now you tell me, always remember, why do you catch hold of the minimum degree of the denominator? Because the numerator you want to expand only to that degree. Don't go to x to the power 6 something something plus x to the power 8 something something and so on. No. No need for higher powers, because this x to the power 4 term will actually get distributed with everything, no? It will get distributed below everything. So what will happen when the power is greater than x to the power 4, on cancelling, you will get x square, which is a positive power of x in the numerator. And x is tending to 0, so this completely will tend to 0. Again, 4, this cancels out, you're left with x to the power 4, which is a positive power of x in the numerator. Again, this will tend to 0. So that is why when your minimum degree of denominator is figured out, the numerator you expand only to that degree, which is degree 4, x to the power 4. Okay, only to that degree, because everything else automatically will become 0. Here, this gets cancelled out. What about the first term? First term, tell me. Here, if you cancel this out, you are left with x square, but in the denominator. Positive power of x in the denominator, and x is tending to 0. So, this complete quantity, bache, will tend to infinity. And this will contradict my fact. This will contradict my fact that my limit is a finite limit. My limit is a finite limit, no? So if I have the first very term, it will tend to infinity. Infinity plus minus anything is infinity only. So it will contradict the fact that my limit is finite. That means I don't want this first term. This I don't want. I don't want it to exist. I don't want it to exist means I don't want any term with degree less than x to the power 4. I don't want any term in the numerator with degree lesser than the minimum degree of denominator. I want nothing less than x to the power 4 in the numerator. This is x to the power 4 se kam. X square is less than x to the power 4. So I don't want this term in the numerator. I don't want this term means I want it to vanish. I want it to go away. I want it to go away means I want its coefficient to be 0. Right? I don't want this term, which means I want its coefficient to be 0. I want 1 minus alpha by 2 to be 0. Please tell me if this is clear. 1 minus alpha by 2 is 0 means alpha is 1. The moment alpha is 1, this first term will vanish. And you will only be left with this term. And what is this? X to the power 4, x to the power 4 cancels out. Minus alpha square by 8 upon, what is this? Minus beta square by 2 minus 1. Yes? Minus beta square by 2 minus 1. This is what is your minus 1 by 16, which is the limiting value. Such a brilliant question, everybody. Please tell me. Please tell me if this is clear. Oh, minus minus is plus. This is plus. Plus 1 by 8. This is plus 1 by 8. This is plus 1 by 8. Okay. So minus from here common. Beta square by 2 plus 1. And then I have this minus cancels out. So alpha square by 8. And you have beta square plus 1 by 2. So beta square plus 2 equal to 1 by 16. Alpha square is nothing but 1 only, na? And 2 into 1, 2 into 4. So what do you have? 4 beta square plus 8 is equal to 16. 16 minus 8 is 8. So beta square is equal to 2. How many of you are getting beta square as 2? Beta square is 2, alpha square is 1. 2 upon 1 will give you 2 as the answer. Isn't this a brilliant question? Tell me. Wasn't this like mind-boggling question? Wasn't this mind-boggling question with so many concepts involved, such rich concept involved? Always remember, first task is to simplify the denominator. When you have figured out the minimum degree of the denominator, then you are going to make the numerator function in accordance with that minimum degree of denominator. Anything, any term sitting in the numerator which is lesser than x to the power 4, I will want it to vanish. So the coefficient will have to be 0. From there you will get the value of one unknown. Anything greater than x to the power 4 will automatically become 0. What will be left is above term and below term, both same x to the power 4. Their coefficients are what is going to give you the limit. Their coefficients is what is going to give you the limit. Is this question understood, everybody? Please tell me. Is this question hashtag HDCC? Very, very important question. Again, this is representing a variety. Representing a variety. Yes, ma'am? Correct? All right. Big smileys on the face. This question, not an easy question. It's 100 percentile question. Not easy. But now that you understood the previous question, it's not difficult as well. Tell me. Very tricky, not a very smooth, but a very analytical question which will literally polish your understanding on differential calculus. Log of 1 plus x to the power 2014 minus log of 1 plus x whole to the power 2014 upon x to the power 2015. There is a certain mindset required to crack this question. And because this is kind of connected to the previous question we did, that is why I had kept that question as the question number 6. So that question number 7 kind of happens to fall on the same line. If we apply LH rule, get factorial in denominator, which comes in the expansion too. Not sure if this is going to be useful. Think. Quickly think. Hi JSP, hello, welcome to the class. Anybody, any clue? If I say what is log 1 plus x, do you remember the expansion? You remember the expansion, anybody? X minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 and so on. Yes? So if I consider log of 1 plus x to the power 2014, what will this look like? And remember, here also there is x tends to 0 where the power of denominator, listen to me very carefully, the power of denominator is 2015. If I talk about least degree of the denominator that we were talking about in the last question also, it is bachche 2015. So anything, if I want a finite limit of this expression, anything less than 2015, I don't want, its coefficient will be 0. Anything greater than 2015 will automatically tend to 0. And from the numerator, catch hold of the coefficient of x to the power 2015. From the denominator, coefficient of x to the power 2015 is 1. That will give you the limit. The ratio will give you the limit. Cool? Cool? Yes? Same approach like in the previous question. Yes, Priyanshu, that's what I'm doing. So you have what? X to the power 2014 minus x to the power 2014 square. That means 4028. X to the power 4028. Oh my God, such big power. Minus x to the power 2014 whole cube upon 3 plus and so on. Now see, I am not interested in anything greater than 2015. Understanding? Anything greater than 2015. If the power is greater than 2015 and there is upon x to the power 2015, on cancelling I will have a positive power of x in the numerator and it will automatically tend to 0. So I am not interested in big powers of x greater than 2015. So only this is my term I am interested from this expansion. Rest everything is like 0 to me. I am not saying it's 0. It's like 0 to me. Like in the previous question, you remember what did I do? In the previous question, you remember what did I do? I showed you, right? I showed you how this is tending to 0. If power of x upar is more than niche, then on cancelling, you will be left with positive power of x in the numerator and eventually the entire term will tend to 0. I showed you, right? Because of the same logic, now I am saying my language, understand the language, that these terms are like nothing to me. They are 0 to me. They are not visible to me. They are absent for me. If I don't consider them also, it's like absent. Absent, okay? 100 percentiler question is what we are targeting. So listen to me carefully. This part is sorted. What about the next part? See, if I consider log of 1 plus x whole to the power 2014, what is this? X minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 plus and so on, whole to the power 2014. Yes, but you can take out an x common, you'll be left with 1 minus x by 2 plus x square by 3 minus x cube by 4 plus and so on. This to the power 2014, this to the power 2014. Now again the same logic. Everybody listen to me carefully. When this goes inside, I will get x to the power 2014. When this goes here, I will get x to the power 2015. When this goes here, I will get x to the power 2016. I'm not interested. I'm not interested in x to the power 2016, 17, 18, 19, 20, whatever. Anything greater than 2015, I'm not interested. Anything greater than 2015, I'm not interested. That means from this term onwards, I will treat like it's not visible to me. Gayab hai. I'm blind to this. I'm not able to see this. This is how you have to train your brain. Don't always start spoon feeding yourself. Please train your brain to do some amount of mental math and play smart to save your time. Because I don't want anything greater than 2015, anything which is giving me greater than 2015 is like it's not there. It's like it's vanished. It's like it's there but it's not there for me. For me, it's not there. So, my first expansion, I will treat it like x to the power 2014. That's it. Yes, it's an infinite expansion, but for me, first expansion is just this much. Similarly, my second expansion for me looks like x to the power 2014 multiplied with 1 minus x by 2 whole to the power 2014. That's it. It is an infinite expansion, but for me, it looks only this. For me, it is only confined to this much. Is this making sense? That is how I have reduced my infinite setup to a finite setting. This is how I have kind of concised my infinite setup into a finitely many terms thingy. Very, very good. Is this making sense, everybody? So my numerator now looks like what? This is x to the power 2014 minus, this is what? X to the power 2014, 1 minus x by 2 to the power 2014 whole upon x to the power 2015. Please tell me if this is clear, otherwise I'm not moving ahead. Otherwise I'm not moving ahead. Huh? So x to the power 2014 minus x square by 2 whole to the power 2014 upon this. Now see the magic. Now see the magic. No, okay, let me write it like this only. Wait a second. X to the power 2014 comes out common. We're left with 1 minus x by 2 to the power 2014 whole upon x to the power 2015. This and this is cancelling out. I am left with 1 minus x by 2 to the power 2014 whole upon x. Now the scenario has changed. Now the least degree of my denominator is 1. Now the least degree of my denominator is 1. So in the numerator, I can see I have 1 minus x by 2 to the power 2014. I will open this up using my binomial expansion, but only till the linear term. I don't want the quadratic, I don't want the cubic. I don't want the quadratic, I don't want the cubic. So 1 minus x by 2 to the power 2014. Remember, 1 minus 1 plus x to the power n is 1 plus nx plus nn minus 1 by 2 factorial. You can do like this. So 1 plus this into minus x by 2 plus something. I am not interested. For me, all these terms are absent. So all I am left with is 1 minus 1007x. No, it's not. It is not. So you are left with 1 minus 1007x whole upon x. That means you are left with 1007x upon x. X cancels out. 1007 is your answer. This is a 100 percentile question, everybody. Has it boggled your brain or not? 1007 is the right answer. It's not a PYQ. Try finding it out. It's not. So all throughout there is limit. I have not written it, but I feel you're mature enough to understand. Yes? Yes? Isn't this a fantastic question, people? Isn't it a fantastic question? Is the concept clear? I wanted to just reiterate the fact that once you have the least degree of the denominator, numerator starts operating according to that. Numerator starts operating or functioning according to that. So whenever you are using expansions in the numerator, always keep in mind that I am only interested to expand till the degree of my denominator. Beyond that, whatever terms come you should be blindsided to them. They should actually not exist for you. So stop looking at them. Stop looking at those terms only and make your finite expansion into make your infinite expansion into a finite expansion. Treat it like a finite expansion consisting of just 1, 2, 3 terms. It will really change the game for you. You will be able to reach your answer faster and in an accurate fashion because your understanding is top notch. It's beautifully clear. Okay? All right, the 7th present we are down with. Is this absolutely clear? Not a supremely easy question, but if you understood this, trust me, you have leveled up your game from today. You've leveled up. 100% you've leveled up. Hashtag HDCC, very good rail facts, Tamil, very good. Question number 8, this is beautiful, this is pretty. Like, you know, that present which has a big bow on top. Yeah, there are bows now with which we tie the present. There are bows on top of the present. This is that present. This is that present. This is going to be solved using a brilliant shortcut. Let's see if you know it. Let's see if you know it. Quickly. हाँ, तो tell me, no? Great. Who's this? Jairam. I love all my students. Yup. Do you remember the shortcut? Do you remember the shortcut? Do you? Whenever you get questions like these form a classic variety. Do not commit the blunder of opening the mod up by computing their critical points, dividing them into many areas, and then for every region, as somebody said, describe the piecewise function. Describe your function piecewise and then comment upon it being differentiable or not. Don't do that. Please don't do that. It is stupidity. It is stupidity. Hi, Ritik. It's stupidity. Nobody from my class, my students are not going to commit this blunder, this mistake, this crime of opening all these mods up and actually describing your f as a piecewise function and then differentiating it and then at all the connecting points finding out its differentiability. Please don't do that. I will teach you a wonderful shortcut which is going to make this question cakewalk for you. See, f of x is mod of 2x plus 1, all right, minus 3 times mod x plus 2 plus, how will you factorize x square plus x minus 2, everyone? Is it mod x plus 1 into x plus 2? Quickly factorize. Quickly factorize. Hi, Arya. This is mod x plus 2 into mod x minus 1. I can write it like this because this quadratic is nothing but x minus 1 into x plus 2. No. So mod of product is product of mod. Now be careful. Look at the shortcut. Mod x plus 2 is sitting commonly in both these terms. So mod of 2x plus 1 is written as it is minus mod of x plus 2 outside. Inside I'm left with 3 minus mod x minus 1. This is a very important step. Taking out common terms. This is extremely important. Okay, you've taken out a common term which is mod of x plus 2 and inside you're left with 3 minus mod of x minus 1. Now the shortcut comes into picture. What does the shortcut say? What does the shortcut say, everybody? The shortcut says if you have two functions f of x into g of x, f is not differentiable at a and along with that g is vanishing at a. If f is not differentiable at a and g is vanishing at a, this implies f into g is differentiable at a. Please write it down. Please write it down. Not everybody knows this shortcut, and this shortcut makes questions like these super simple. Super duper simple. And vice versa is also true. If f is not differentiable at a but g of a is not equal to 0, then f into g is not differentiable at a. It's not differentiable at a. Cool? For example, let me treat this as f of x and let me treat this as g of x. Now listen to me, how am I applying the shortcut? See, f is not differentiable at minus 2. Mod of x plus 2 has a V-shaped graph which has its vertex at minus 2. So clearly it's not differentiable at minus 2. But g of minus 2, can you calculate? Minus 2 minus 1 is minus 3. Mod is 3. 3 minus 3 is 0. This means f into g. This means this complete function, this complete function is differentiable at minus 2. It is differentiable at minus 2. Similarly, if I again write f of x as mod of 2x plus 1 minus mod of x plus 2 multiplied with 3 minus mod of x minus 1. Now I do ulta. This is my f of x. This is my g of x. I know g is not differentiable at 1. You can see, right? G function is not differentiable at 1. Mod of x minus 1 is not differentiable at 1. So 3 minus mod x minus 1 will also be not differentiable at 1. Because when you are adding a 3, it is just shifting the graph up or down. Adding a constant or subtracting a constant will shift the graph up and down. It will not change the fact that my function is not differentiable at 1. Okay, and along with that, f of 1, is it 0? F of 1 is mod of 1 plus 2, which is 3. This is not 0. G is not defined at 1, but f of 1 is not 0. That means what? F into g is not differentiable at 1. Oh. So f into g though we have examined. F into g, from here to here, I know it is differentiable at minus 2 but not differentiable at 1. And if I talk about this particular function, this is not differentiable obviously at minus half. So out of the 3 critical points which you were able to see right in the beginning, minus half, minus 2 and 1. At minus 2 it's differentiable, so only minus half and 1 are the points where the function is not differentiable. Is this clear? The answer is 2 points, not 3 points. So initially it seems like it's 3 points, but actually it's 2 points. Many students in this question, it's a PYQ. Many students in this question have marked 3, but 3 is wrong. I did not want to bring options for you, so that you're not able to see 2. I wanted to check what strikes you right in the beginning. Is it 2 or 3? Is the shortcut understood, everybody? First you check where f is not differentiable. There, if g is 0, then the function is differentiable. If g is not 0, function is not differentiable. Next, vice versa. G, now you check where is it not differentiable, and along with that, is f equal to 0 there? If it is, product is differentiable. If not 0, then product is not differentiable. Ritik, this is differential calculus. Is the shortcut clear, everyone? This present was a very pretty looking present. I hope you liked it. I hope you liked it. Yes? I hope you liked it. Now, this is a tricky PYQ. Tricky PYQ as in easy plus tricky. Tricky, some questions are tricky in the sense they will not strike you. For you to have its approach in your head striking, that is tough. That kind of a tricky question, this is not. No. One type of a tricky question is that it's conceptually very tough to find out the approach to solve it. Next type of a tricky is which is very easy, but still you mess up in that question. This is that question. It's very easy, but students have ended up messing up this question. Trust me. In that way, it's tricky because many students have committed errors in this question. It's again a PYQ. It's a JEE Main PYQ. Many students have committed errors in this question. So it's that way tricky, but approach-wise, concept-wise, it's not tricky. Approach-wise, concept-wise, it's not tricky, but this question is kind of a slippery area for students. I don't know why. It's a slippery, not I don't know why, I actually know why, but a lot of students have slipped here in the past. Tell me. Tell me. Consider this function. Is it monotonic on minus infinity comma 0 union 0 comma infinity because it's not defined at 0? So is it monotonic? That means increasing or decreasing. Is it not monotonic? Monotonic only on 0 comma infinity, monotonic only on minus infinity comma 0. So the approach is very simple. F of x is given to me. I want to compute f dash x and then check, right? So let's do that. If I talk about f of x, see, it's mod x non-zero. That means x can be positive or x can be negative, and lastly x is 0. When x is positive, you are having 2 minus sine of 1 by x into x. Next, 2 minus sine of 1 by x into minus x. And third, 0 when x is 0. Yes? Yes or no? Let me multiply and write this. This is 2x minus x into sine 1 by x. Again 2x plus or minus 2x plus x into sine 1 by x and then 0. So tell me, if I just consider, I want to compute f dash, right? I'm going to compute f dash for this also, corresponding to x positive and x negative. I don't care about x equal to 0, but for x positive and negative, I want to consider because my options say check whether f is monotonic after 0 or before 0. Let's see, Himanshu is saying it's monotonic only before 0. Chalo, let's see. I am going to compute for x positive. Let's check. 2x, differentiation is 2. Okay, minus x into sine 1 by x. First function, differentiation of second, plus second, differentiation of first. So this x cancels out. You're left with 2 minus cos of 1 by x into minus 1 by x plus sine 1 by x. Tell me, what can you say about its sign? What can you say about its sign? What can you say about its sign? Positive, can be positive and negative. See, this is like 2 minus sine of 1 by x. Club this together. Plus 1 by x into cos 1 by x. Now see, sine is a function always sandwiched between minus 1 and 1. So 2 minus something which is bounded between minus 1 and 1, this is always positive. But this is the positive na, for every x non-zero, this part is pakka positive. But look at this part. If your x is 1 by 6, suppose, then you will get 6 cos 6. 6 is greater than 2 pi. 6 is greater than 2 pi. It's going to be positive. Very good. But if I take x as 1 by 4, you will get 4 times cos 4. 4 is just greater than pi. Tell me, just greater than pi, it will be negative. So I don't know. 1 by x cos 1 by x. This can be positive or negative. This can be positive or negative, a very big negative value, small positive value, or a big positive value, whatever it is. Whatever it is, the sum can come out to be positive or negative. The sum can come out to be positive or negative. So f dash is not coming out to be of a uniform sign after 0. So it's not monotonic after 0, pakka se. It's not monotonic after 0. Similarly, when you will check for x less than 0 and compute f dash, again it will not have a uniform sign even before 0. It's not monotonic before 0. So it is actually not monotonic. It's actually not monotonic. It's actually not monotonic. Just imagine such an easy question, but this is one of the questions which students have committed errors in drastically. Tons of students have committed errors in this question. Just because the concept or the idea is not clear. Analysis is not happening in a very refined manner. That's not happening. They are able to understand the language of the question, A, correct. B, they're able to understand what options are demanding for, correct. Next, they know I have to differentiate, very good. But after that, how to conclude? Because see, the expression which is there in f dash is not a very good looking expression. You can't directly look at it and say, oh, this will be positive, oh, this will be negative. You will have to analyze it, go deeper, unlayer it. Like 2 minus sine 1 by x, it was very simple for us to decode it and say, okay, this will always be positive. But what about 1 by x cos 1 by x? I had to analyze, no? So in questions like this, analysis plays a big role. So analytical thinking is what comes to the test. It is not a lengthy question. See, it got completed in 2 slides. And with you, though, it would have taken just half a page. Right now, though, I'm explaining some writing in a very descriptive manner. But if I was a student in solving, it would have not taken much space from my side. It's a very analytical question, not a lengthy, mechanical, calculation-heavy question. No. But questions like these actually trap you. They actually trap you. Okay? Is this question clear, everyone? Please tell me right now. Stop me right now if it's not clear. Please stop me right now if it's not clear. I'll share with you a beautiful trick which you will really love in this question. This is one of my favorite questions. This is one of my favorite questions. Why? Because you can solve it like this. It says f is from minus 1 comma infinity to r be defined as f of 0 is 1. F of x is log of 1 plus x upon x for x non-zero. What is the function? Where is it increasing? Where is it decreasing? Quick, quick, quick. Where is it increasing? Where is it decreasing? Too much blue, no? Slides blue, my t-shirt blue, the cup blue. Too much blue. What will you do? Obviously, if you're talking about log of 1 plus x, my 1 plus x has to be positive, so x has to be greater than minus 1. No doubts about this. X has to be greater than minus 1. That is why the domain is minus 1 comma infinity. That much is so clear. I want to talk about it increasing and decreasing. The problem is when you compute f dash, you will get second function differentiation of first minus first differentiation of second upon second whole square. So x upon 1 plus x minus log of 1 plus x whole upon x square. This is your f dash x. That means your f dash x is actually a combination of algebraic function and logarithmic function. Oh my god. What is this? Huh? It's a combination of algebraic function and logarithmic function. It will be difficult for us to calculate whether it is positive or negative or 0. Where is it positive? Where is it negative? Where is it 0? It will be difficult for us to find this out because my expression of f dash is a mixture of algebraic and logarithmic function. Yes or no? What will you do then? I have differentiated now, Vijay. Now what will you do? Now what will you do? What will you do? It's a beautiful trick which will come into action. Beautiful trick. Yes, for the critical points only, look at the options. The options here are giving you the strategy, the shortcut. Increases in minus 1 comma infinity, increases in minus 1 comma 0, decreases in 0 comma infinity. That means it is saying that 0 is point of maxima. Third, decreases in minus 1 comma 0 and increases in 0 comma infinity. That means 0 is the point of minima. And then it says decreases in minus 1 comma infinity. So I have to talk about 0 being a critical point. I have to talk about technically 0 being a critical point. So about 0, I have to check the sign change. About 0, I have to check the sign change. So do the basics. Whenever in life you're confused, go back to the basics, go back to the fundamentals, pick up a point, hit and trial, which is greater than 0 and pick up a point which is less than 0 and lies in the domain which is minus 1 to infinity. So I have picked up a number which is less than 0, that is minus half, picked up a number which is greater than 0, that is 1, and now I will calculate f dash minus half and f dash 1. Can you tell me what is the sign of f dash minus half? Hi Kirtika. Can you tell me? Minus half. So you will have minus half upon 1 minus half is again half. So you are getting minus 1 minus log of 1 minus half, log half. Upon half whole square is 1 by 4. So this is what? 2 to the power minus 1. And this is plus. What is log 2? 0.693. Minus 1 plus 0.693 is negative. Negative upon 1 by 4 is negative. Merry Christmas. Merry Christmas. Is this cool? Similarly, what is f dash 1? It is 1 by 2 minus log 2 whole upon 1 square. Again, 1 by 2 minus 0.693. Again, it's negative. 0.5 minus 0.6. So it's negative before 0, negative after 0. If you still have doubt, you can plug in x as 2, x as 3 and also check throughout. At every point it will come out to be negative. But what is sufficient for you to check? Just take one number before 0, one number after 0, keeping in mind that we have to take the inputs within the domain. Do not go outside the domain. Don't take minus 2. No. Because my domain is from minus 1 to infinity. Is this clear? If it is throughout negative, f dash is throughout the domain negative. F dash is throughout the domain negative. That means D is the correct option. 0 is neither a point of max nor a point of min. F of 0 is 1, that is fine. F of 0 is 1, that is fine. But my function is throughout continuous and decreasing. Intersecting y-axis at 0, 1. Is this hashtag HDCC everybody? Absolutely clear. This is a shortcut which you must remember. This comes in very handy when your derivative looks like a combination of 2-3 functions which are difficult to comment upon. You can't comment upon a combination of algebraic and logarithmic function, right? It's very difficult. It's very difficult, right? You can, if you compute double derivative, then equate with 0. Why do you want to move into that direction? So always remember, in questions like these, you take the hit and trial approach and very quickly reach the answer. Okay, we wanted to find out whether it's increasing or decreasing, so we found out the derivative. The derivative came out to be a mixture of log and algebraic, which is very difficult to assess as to what will be its sign, positive or negative. Where is it 0? I don't know. So I used the hit and trial method. I looked at the options. 0 was the point kept to test. So around 0, I want to check the sign change. So after 0, I considered an input 1. Before 0, I considered an input minus half. Both are lying in my domain. At both the inputs, I checked the sign of f dash. It came out to be negative. That means my function is strictly decreasing about 0. In fact, throughout my domain, it's decreasing. Okay? Devi, BWA, is it clear? Is it clear? Alrighty, let's go to the next question. Couple of more questions and then we'll wind up the class. How are you sure it will be negative? Try it out, no? When I computed f dash minus half, what did it come out to be? It came out to be minus 1 minus log 1 by 2 upon 1 by 4. So it's minus 1 plus log 2 upon 1 by 4. Log 2 is 0.69. So minus 1 plus 0.69 is what? Negative? No, negative upon 1 by 4 is negative only. That is how. Okay. Is it clear? When you use the first derivative test to write the sign of f dash as positive to negative around any critical point, this is what is the logic. You take any one input about the critical point on both sides, whatever is the sign of that at that input, same is the sign in that entire region. Correct? That's what we do in mod functions. That's what we do in first derivative test. Yeah, that is enough, Vijay. That is what I'm saying. It's enough to check for two values, one after 0, one before 0, because 0 is the only input kept to test as per the options. Come to this question now. Very nice. It says f is this in minus pi by 2 comma pi by 2. It has exactly one maxima and exactly one minima. Exactly one maxima, exactly one minima. This means something. When you say that the function has exactly one maxima and exactly one minima, this means what? This means what? That f has exactly two critical points. One is the point of max and one is the point of min. F has exactly two critical points. One is the point of max, one is the point of min, which means, let's say alpha and beta are the critical points. Then it's like plus, minus, plus, increasing, decreasing, increasing. Alpha is the point of max, beta is the point of min. This is the scenario. You have to visualize what the question is saying. The English language which is written in the question, convert it into mathematical language and start visualizing the scene. Start visualizing the scene. Exactly one maxima, exactly one minima. That means there are exactly two critical points. One will represent point of max, one will represent point of min. It's a continuous differentiable function. Can you see this? Yes. So nowhere f dash is undefined. You will get critical points only by plugging in f dash equal to 0. And that will give you two answers. That will give you two answers, alpha and beta. Okay? Okay? But what are the critical points? Let's see. F dash x. Tell me. 1 minus cos square x is sin square x, no? Okay. So first I'll write fx, which is sin square x, lambda plus sin x. Tell me. Yes or no? Yes? Let's differentiate. First function, differentiation of second plus second 2 sin x cos x. Now tell me. Quickly tell me. I can take out sin x into cos x common. I'll be left with sin x plus lambda plus sin x into 2. That's it. Now, you know, as a matter of fact, when we are talking about minus pi by 2 open interval, cos is pakka se positive. Cos is pakka positive. That means when I equate this with 0 to get my critical points, this cos has no relevance because it's always positive. So I will have sin x into sin x plus 2 lambda plus 2 sin x. So you basically have 3 sin x equal to 0. This gives you sin x is 0 or sin x is equal to minus 2 lambda by 3. Yes? So in minus pi by 2 and pi by 2 open interval, remember the graph of sine function. This is pi by 2 and this is minus pi by 2. In minus pi by 2 open interval, only at 0 sine is 0. Only at 0 sine is 0. Yes, that means from here you get x is 0. And from here what do you get? Sin x is minus 2 lambda by 3. Sin x is minus 2 lambda by 3. At what value of x will sin x be minus 2 lambda by 3? Arey baba, minus 2 lambda by 3 can come as an output of sine function if and only if mod of minus 2 lambda by 3 is less than 1. If and only if this output minus 2 lambda by 3 lies in the range of sine. If this quantity minus 2 lambda by 3 lies outside minus 1, 1 closed interval, there is no x for which sin x is this. For my sin x to be this, this answer minus 2 lambda by 3 has to be lying in the range of sine. And I want it to lie in the range of sine because if it will not lie, I will not be able to get another critical point from here. Only 0 will be my critical point, which is a contradiction because I want 2 critical points. That means for one more critical point, this quantity has to come from minus 1, 1 closed interval. This is less than equal to 1. Tell me. That means lambda is sandwiched between minus 3 by 2 and 3 by 2. Please check this. Yes, lambda belongs here. Aryan is saying yes, on the Rankplus, IIT JEE Rankplus is the channel's name where I teach the same content but in English. Okay? But of course, we are ahead in the game on the English channel. So if it's not too much of a problem, please continue joining sessions here. The frequency is more on this channel than on the Hindi channel. If my lambda comes from here, then definitely there exists some alpha for which sine alpha is equal to minus 2 lambda by 3. So now this way I have 2 critical points. One is x equal to 0, one is x equal to alpha. Yes or no? Sin x equals 0 has given me x equal to 0 and sin x equal to this has given me x equal to alpha. So 2 critical points have pakka se I have obtained. But only when lambda is sandwiched between minus 3 by 2 and 3 by 2. Now problem is, this is wrong, but what about A and D? Oh, this will be just less than 1, no? Yeah. Because at minus pi by 2, it's minus 1. At pi by 2, it is equal to 1. And minus 2 lambda by 3 is not minus 1 or 1. So x cannot be minus pi by 2 or pi by 2. Tell me. Lambda is sandwiched between minus 3 by 2 and 3 by 2. Sure. But what about A? What about D? Will 0 be excluded or not excluded? Will 0 be excluded or not excluded? Listen to me carefully. If lambda is 0, is there any panga? If lambda is 0, f of x will come out to be what? 0 plus sine x is sine x. So you will get sine square x into sine x, which means sine cube x. So f dash x will be 3 sine square x into cos x. 3 sine square x into cos x. And we are talking about x belonging to minus pi by 2, pi by 2. This is positive. This is positive. So completely it's positive, which implies f is strictly increasing in this interval minus pi by 2, pi by 2, which is a contradiction. Because if a function is strictly increasing in an interval, that means it's not taking any turns. If it's not turning, if it's not changing its behavior from increasing to decreasing or decreasing to increasing, it will not be able to give rise to points of maxima or points of minima. And this function has exactly one maxima and exactly one minima. So it's increasing, turning, decreasing once, decreasing, turning, increasing once. That's it. That's it. That's it. But if f is throughout strictly increasing, it will not turn. That is why lambda is not allowed to be equal to 0. I will have to push it out, kill it out. So this is wrong. D is correct. Very beautiful question. Bariki. We see na devil lies in the details. Those details were there in this question. Statement is very simple. The set of all real values of lambda for which this function has exactly one max, exactly one min. But first you had to visualize. Exactly one max, exactly one min for this continuous differentiable function means it has exactly 2 critical points. Right? Exactly 2 critical points. So when you computed f dash, one came out to be 0, other came out to be alpha. I don't care what alpha is, but alpha has to be another critical point. I want 2 critical points, 0 and alpha, but alpha comes out to be a valid acceptable critical point only when lambda is sandwiched between minus 3 by 2 and 3 by 2. But the moment I got this, I was very happy. I saw it right in the first option, minus 3 by 2, 3 by 2 open interval. And this is what happens in the excitement in the examination hall also. You tick it correct. You're like, minus 3 by 2, 3 by 2 open interval, correct. But right in option D, there is trick hidden, except 0. Because when lambda comes out to be 0, the condition doesn't match. The function no more has exactly one max, exactly one min. It actually has no max, no min. That is why 0 has to be excluded from within the minus 3 by 2, 3 by 2 open interval. Okay, so be very, very careful with the options. They deliberately give you the option which you've got as option A, so that in excitement you mark it. But then option D is actually correct. You are saying, where can we get the PDF notes? Bache, 100 times I've told you, please join the Rankplus JEE English channel on Telegram. It's by the same name. Please join. All the PDFs are uploaded there. Okay, that is the platform to get the PDF. There is no other platform to get the PDF. And you can also join Study with Bhoomika Ma'am Telegram channel. There also I will upload the PDF. But come there and text me which PDF you've not got. I will check if it is kept on the Rankplus JEE English Telegram channel or not. If not, I will be uploading it on my channel, which is Study with Bhoomika Ma'am. Okay, Himanshu, please join it. It's Study with Bhoomika Ma'am. Is that cool? Please don't worry about the PDFs. Okay, when you are in the class, try to be as much involved as possible in the class and prepare your notes along with me. But I understand you need the notes. I will be uploading them. Please don't panic. Don't spam like this. Please maintain some dignity in the class. Don't spam like this. Okay? I understand your concern, but we have a proper way to do so, right? Come on the Telegram channel and let me know. Study with Bhoomika Ma'am. Alrighty? Alrighty, this is the last question for today and a bomb question. This is a bomb question. Let's see. Let's see if you are able to crack it or not. It's a very, 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 very nice JEE advanced question. Tell me. Okay. I will upload. Don't worry. Please join study with Bhoomika Ma'am. Today itself I'll upload. Okay? Don't worry, yeah. Don't worry. I'm there. Don't panic. Tell me. For a polynomial g of x with real coefficients, let mg denote the number of distinct real roots of g. Please make sure you understand g is a polynomial. That means it's continuous and differentiable. Correct? Suppose as the set of all polynomials with real coefficients defined like this. For a polynomial f, let f dash and f double dash denote its first and second derivative. Then the minimum possible value of mf dash plus mf double dash where f belongs to S is what? Tell me. Quickly tell me. I am not interested in computing what my A0, A1, A2, A3 will look like. No. No interest. No interest at all. No interest at all. It says f is a polynomial coming from this set. F dash and f double dash are its first and second derivative. Mf dash means number of distinct real roots of f dash, number of distinct real roots of f double dash. Now you know as a matter of fact, if f is a polynomial, see, this is a polynomial, x square minus 1 whole square. This is a polynomial, cubic polynomial, right? This is polynomial and this is a cubic polynomial. So the product is certainly a polynomial. Whatever degree, I don't care, it's a polynomial. It is continuous and differentiable. Its derivative is continuous and differentiable. Its double derivative is continuous and differentiable. When your functions are such beautifully defined, when they are continuous and differentiable, what do you do? What do you know? What do you know? That if your function is continuous and differentiable, which has, let's say, a, b, c as 3 roots. This is my function f, which has 3 distinct real roots a, b, c. Then for it, because it's a continuous differentiable, beautifully drawn, smooth function, it is intersecting the graph, it is intersecting the x-axis at exactly 3 distinct points. So f has 3 distinct real roots. F has 3 distinct real roots. Perfect. That means it is turning at least 2 times. Are Baba, from A, at A it is intersecting the x-axis, then coming back and intersecting at C. B pe it is intersecting the x-axis, then going back and intersecting at C. So at least once between A and B it will have to turn. At least once between B and C it will have to turn. You will say, ma'am, can it turn more times? Yes, of course. Yes, of course. This is A, this is B, this is C. 3 distinct real roots. Between A and B, it is turning 1, 2, 3, 4, 5 times. Between B and C, 1, 2, 3 times. But minimum, if f has 3 roots, it will turn 2 times. Minimum, if f has 3 roots, it will turn 2 times. Maximum, it can turn more than 2 times, more than 3 times, 4 times, 5 times, 6 times. Maximum pe there is no bar. Minimum pe there is a bar. If there are 3 zeros of f, yes, if there are 3 zeros or roots of f, a, b and c, from A to go to B, it will have to turn at least once. From B to go to C, it will have to turn at least once. So, turn twice. Minimum times it will turn is twice. That means f dash is 0 at, let's say, x1 lying between A and B. And here also f dash is 0 because the tangent is parallel to x-axis at x2 lying between B and C. So if f has 3 distinct real roots, f dash has at least 2 distinct real roots. And I hope I don't need to tell you that roots of f and roots of f dash are distinct from one another. Roots of f dash lie between roots of f. Can you see x1 and x2? Between A and B somewhere it will turn, no. Between B and C somewhere it will turn, no. So the roots of f dash, where f dash is 0, where tangent is parallel to x-axis, will be lying somewhere between the zeros of f. Okay? So the roots of f and roots of f dash will be distinct. Similarly, if f dash has at least two distinct real roots, if the graph of f dash is intersecting the x-axis at 2 points, its derivative will have at least one less root. F double dash will have at least one real root. And all these roots will be distinct from one another. So it's the same. If f has 5 roots, it's a continuous differentiable function intersecting the x-axis at 5 distinct points. Its derivative will have to have at least 4 roots. Because for the graph of f to intersect x-axis 5 times, it will have to turn at least 4 times. So f dash will have at least 4 roots. Now if f dash is cutting the x-axis 4 times, its derivative f double dash will have at least 3 roots. Because if f dash is cutting x-axis 4 times, it will turn at least 3 times. So its derivative, which is f double dash, will have at least 3 roots. So if f is a continuous differentiable function having n roots, remember, if f has n distinct real roots, then f dash has at least n minus 1 distinct real roots and f double dash has at least n minus 2 distinct real roots. All these are distinct from one another. There is nothing common in the roots of f, f dash and f double dash. Very important. Why am I telling you this? This was the concept which drives this question. This was the concept which drives this question. Tell me, why am I telling you this? If I take any random function from set S, it will look like x square minus 1 square a naught plus a1x plus a2x square plus a3x cube. Let me say this is a cubic polynomial. So this looks like x square minus 1 square into something cubic. Okay, fine. Fine. Now I know as a matter of fact that x square minus 1 whole square is 0 when x is 1 and minus 1. So I know for sure that f of 1 is 0 and f dash and f of minus 1 is also 0. Itna to I know, pakka se, for sure I know. But if I compute f dash, what will I get? First function, differentiation of second, dash of the cubic polynomial plus cubic polynomial into what? 2 times x square minus 1 into 2x. Yes or no? Tell me. So you basically have x square minus 1 common. You will have x square minus 1 into dash of cubic plus cubic into 4x. And you want to compute critical points. You want to compute the turning points, no? So x square minus 1 is 0. This is giving you x is plus minus 1. X is plus minus 1. From here also I might get some roots. Might get some roots. But fact of the matter is, where are the options? Minimum value is asked, na? Fact of the matter is, f dash of 1 is 0 and f dash of minus 1 is 0. So did you check? F was x square minus 1 whole square into cubic. Now this cubic also might have some of its own zeros. But I can for sure say that at 1 and at minus 1, f is 0. Similarly, when I computed f dash, I had this lamba sa long expression which might give me some roots. But this x square minus 1 factor sitting outside, when that gets equated with 0, I get 2 roots of f dash 1 and minus 1. So for 1 and minus 1, I can 100% say, for 1 and minus 1, I can 100% say that f and f dash both are 0. F and f dash both are 0 at these points. Is this making sense? Now please listen to me. I am interested in minimum roots of f dash, minimum roots of f double dash. Now see, if f of 1 is 0 and f of minus 1 is also 0. If f of 1 is 0 and f of minus 1 is also 0, and I want my f to be of such a figure which gives me minimum turns, because as many times f will turn, those many will be the roots of f dash. Correct? Listen to me. This is minus 1, this is 1. One scenario can be f of minus 1 is 0, f of 1 is also 0. Baba, if f of minus 1 is 0, f of 1 is also 0, that means between minus 1 and 1, minimum one time so it will have to turn. Minimum one time so it will have to turn between minus 1 and 1. But in this case, what happens? Both minus 1 and 1 are points of minima. Or one more thing can happen. This is minus 1, this is 1. You can have something like this. F of minus 1 is 0 and f of 1 is also 0. Again, between minus 1 and 1, at least once the graph will have to turn. In this case, but both 1 and minus 1 will be points of maxima. Okay, and if I want minus 1 to be point of maxima, 1 to be point of minima, or minus 1 to be point of minima, 1 to be point of maxima, what will I do? See? Somewhat like this things will have to happen, no? Somewhat like this things will have to happen. Something like this, yes or no? Or something like this. This is 1, this is minus 1. So here this is point of minima and this is point of maxima. Here this is, this is maxima and this is minima. Here ulta is there. This is point of minima and this is maxima. But in this case there is a problem. In this case the graph is turning how many times? 1, 2, 1, 2. Yes or no? Yes or no? If both minus 1 and 1 are points of maxima, then graph will turn at least once. If both are points of minima, graph will turn at least once. But if one is a point of max, one is a point of min, graph will turn at least twice between minus 1 and 1. I want minimum. Because I want minimum, I am not interested in this setup where one point is point of max, one point is point of min, because this is not giving me minimum turns of f. This is not giving me minimum turns of f. I am getting f turning minimum number of times when both minus 1, 1 are points of max or both minus 1, 1 are points of min. In that case, f is turning how many times? Between minus 1, 1 it's turning once, at minus 1 it's also turning, at 1 it's also turning. So if minus 1, 1 both are points of minima, the function is turning thrice. Yes, the function is turning thrice. If both are points of maxima, again the function is turning thrice, at least thrice. But if one is max, one is min, the function will turn 1, 2, 3, 4 times, Baba. At least 4 times. This is not giving me minimum. So minimum is this only when both are points of max or both are points of min. In this scenario, f will turn at least thrice, which implies roots of f dash. Real and distinct roots of f dash will be 3. Therefore, real and distinct roots of f double dash will be 1 less, that is 2. So my answer is 5. How many of you all understood? But in this case, yes, we are not getting the minimum value in this case. You can say, na, ma'am, why are you making both minus 1 and 1 as both points of minima or both points of maxima? One can be max, one can be min. Yeah, it can be. But in order to achieve that situation, my graph will have to turn at least 4 times. 1, 2, 3, 4. It can turn more times also, but at least 4 times so it will have to turn. So this setup is not giving me the minimum number of turns. Minimum number of turns means minimum roots of f dash. Because at every turn, tangent is parallel to x-axis, derivative is 0. This setup is giving me minimum number of turns. When both -1, 1 are points of max or points of min, in this case, between -1, 1, the graph will turn at least once. That means overall the graph will turn at least thrice. Lesser than that, I can't get. See, greater than that I can get because my cubic can give me more zeros. This factor can give me more roots of f dash. More though I can get, but minimum how much is possible I have to answer. That is why I did not disturb the cubic factor here and cubic factor here. The certain and definite part, which was x square minus 1, I have only played my gamble over there. Here also in terms of f, I have only computed zeros of f from the factor x square minus 1, which are 1 and minus 1. And here also when I have differentiated, I have only played my gamble upon x square minus 1 equal to 0. 1 and minus 1. So I can get more zeros of f and f dash, but minimum I want. Minimum I want, so I have only and only worked upon the definite part, which is x square minus 1. Cubic polynomial, its derivative, I am not concerned at all. Not concerned at all. Is this question clear? I don't think anybody will explain you with this much clarity, guys. Is it absolutely clear? Is it absolutely clear? Huh? Is it absolutely clear? Everybody, I'm going to give you this question for homework. I had recorded a YT short way back on this. It's a very famous functional equation. Very famous functional equation. I hope you know how to calculate this. Do you? 1 by 40 plus 39 by 40 is 40 by 40. 2 by 40 plus 38 by 40 is 40 by 40. So you compute what is f of x plus f of 1 minus x. That's the hint. Okay? So please try this question out. It's very famous and important functional equation. Let me know in the comments below what is the answer you are getting, and I'll give you one more homework question. One more homework question I want to give, which is this one. This talks about fog not being differentiable. What are the points at which fog is not continuous and fog is not differentiable? So this question will test your knowledge upon writing the composition function fog. F is known to you, G is known to you. First you clearly describe F and G and then start writing what is FOG. This question will test you upon writing FOG number 1, and then of course continuity differentiability is an easy part that you know how to do. I have already done that in the session today with a couple of questions. But computing fog, writing what that piecewise function looks like, f of g of x, that is the major task. So 2 questions for homework, one from functional equation, one corresponding to the continuity differentiability of the composite function. Please let me know in the comments below what is the answer, and if there is any doubt, again I'm saying for the last time, please join the Telegram group Study with Bhoomika Ma'am. I will be sharing the PDF right now in a couple of minutes on the same channel. On the same channel, I'll share the PDF. Just give me 2 minutes. I'll just save and upload it there. Okay? Thank you so much, folks. A very Merry Christmas to all of you. I hope you liked today's class. Do not forget to hit the like button and share this session with as many folks as you can. Of course, it's a very new, very small channel. It'll really help us if you help us grow. Okay? The motivation has to go both ways. Correct? Thank you so much. Bye-bye. All right. Take care, guys. Bye.